In this video we're going to look at some of the performance optimizations I've made in this game so that it's possible to have large levels with tens of thousands of highly detailed meshes and to make this all work as a viable VR game. The main target I have aimed to meet is that the frame rate should be a relatively stable 90 frames per second, and this frame rate should be achievable on almost any VR capable PC hardware released within the last 6 years. Most indie developed VR games tend to have very small playable areas of less than 20 meters by 20 meters where the player can move around in, or that the play area can be quite large but often lacks detail. In this game it's quite common to have playable areas that are 200 meters by 200 meters. For example, the multiplayer level is a 500 meters by 500 meters area, and as you can see in the footage, the environments can be quite detailed. To make large playable areas, I rely heavily on procedurally generated content, which is only loaded when the player is close enough to interact with it. In this video I'm going to talk about how I reuse a relatively small set of streaming levels in various combinations to create much larger playable levels, where the player could have a very different playable level with each playthrough. For those who don't wish to watch the entire video and just want the basics of how I made these optimizations, it comes down to one of four things. 1. Where we have large open areas and no streaming levels, I'm using a lot of distance culling and fog to hide things popping up on the horizon. 2. Where I'm using streaming levels, I only show the levels that the player can potentially interact with, and hide the parts where the player has finished with and moved on to a different area. 3. Where we have NPC characters, these only become active when the player is near enough to interact with them. Should the NPC move too far away from the player, they'll transfer their controller to a closer NPC. This way we can keep the number of active NPCs down to prevent the game thread from becoming too complicated. 4. I've done some very aggressive optimizations that allow me to make frame generation very cheap, as in thousands of draw calls and on hundreds of thousands of primitives, all done in under 10 milliseconds a frame. In this part we're going to explain the world management plugin, which is the procedural level generator that I use to generate the levels for the randomly generated content. The history of the plugin is that I got a free project from the Unreal Marketplace in one of their monthly deals, and this project was not easy to work with. It had a really good idea of using streaming levels to create complete rooms that are then tiled around each other to build up a underground bunker or something like that, and I really liked the idea, but the implementation was just terrible. It was basically just a collection of race conditions, infinite loops and potential memory leaks that would eventually produce a level, but yeah, it was very slow and it was not easy to work with. So yeah, I created my own version in C++ that was much faster and generally worked so much better. And yeah, that's how the plugin originally created. So I'll show you go over how it creates the levels. So basically what happens is you have a room template, and then around this template we can add on extra rooms to that template. So we use a room area reserved called a cell, and then those cells have level hooks around the edges that we can then use to add on a room. So for example, if we reserve cell B5 here, we have a nice yellow. Actually no, we'll go for something that stands out a little bit more. We'll go for blue. Okay, so we reserved cell B5, and that's just the one cell, and we have the 4 cells around that we can use for level hooks. So we reserve cell B5, and then we pick one of these 4 cells around it as a way to build out from there. So if we take C5 over here, and then we reserve this with a different room shape template, so we reserve, say, 2 cells here, and we'll call that purple. So we have our original with the 3 cells remaining around there, but we can level hooks remaining. We can reserve there, plus we've got an extra 5 around the edge here. So from here, added on to the 3 we had there. So, and then we would build out from there with another room. It could come out from any one of the cells that we've got from there. So if we take it from there, and then we build out with a different shaped room again. So shape there, and we'll reserve that with another colour. Let's go for red or something. So we have our rooms that we've reserved, and we can't reuse these coloured cells. We can only add on parts around the edge where we have 3 level hooks to add on with. So all these white cells around the edge here where we've not used those, and then we have extra level hooks along these sides down here and down here. And then we'll just build out from there with other colours and other rooms. So we'll go for another that back to red, and we'll go for it could be a different another copy of the same room. So for example, we could have another copy of the same room there, and then we have another room coming out here. That's a different colour. Then say another room which could be another copy of our purple room. Okay, so if we go over to the Unreal Editor, we'll show how this works in practice. So we start from our cell B5 as we did on the spreadsheet, and then we would have this cell reserved, and then we would build out from there to from there, and if we go out from here to D5 as we did before, and then we would reserve the same room again like we did. So like so, and then from out here we would have reserved the cells just like we did before. So we started from here, then we reserved 2 cells here, and then we reserved this red room here. So we go down here, reserve the red room, which would be that one, and that one, that one as well. So we would come out at this point, and then we reserve a room here. And then we would build out from these doors in the same way as we did before. And then that builds up until you've gotten a level, complete floor, and then you can start working on the next one from there. Okay. So if we hide those, and we'll generate the first floor. So we generate the first floor, and it would have the copies of the same rooms just tiled around each other. So for example, this is the second room that we created here, a copy of it, and then we just have these go around. This generates the entire level using copies of the same rooms over and over again. Okay, each floor has to have specific requirements so that it can be considered a valid floor, and the requirements for the ground floor are that it must have a transition room, which is why we've got this part poking out top here, and the boss room, which is why we've got this green square thing here. This is where the boss spawns for this particular level. So basically what happens is the player spawns in at the top area, and then they have to work their way down to the bottom floor. So for example, if there's 10 floors, they start from the 10th floor and they work all the way down to floor 0 where the boss is, and then they have to kill the boss to complete the level. So for example, we generated floor 0, and then we have the place to start floor 1. We always start from the level hooks on each floor that we've created from the previous floor, so that the player can always walk through between the floors. If we always started from, say, in the center here, and then we would possibly get areas where the player can't walk through to unless they walk down from the top floor, this floor, until they go. So they would have to go through one floor, then back up, walk down along this floor, and then walk back up to this part to complete the level. So for example, if we've got the way we've got this set up is that we have this door closed until the puzzles have been completed on this floor. Then the player can't complete that level because they can't go through this door to complete the rest of the floor and then go back up because they've it's just it's that would be an invalid floor. So we always make sure that we only have just the one transition room on each floor, or at least one transition room on each floor, so that the player can make sure they can access the entire area. It's generated kind of like a maze, where you start at either the start or the end, and then you work your way out to the edge or work your way into the center until you've randomly selecting tiles until you've eventually got a path for the player to walk through, and then you build off from that path to generate a maze. We work in a similar way here, so we generate a start room and then we just build out from that until we've got the complete floor, and then we can build out for the next floor above and above until we've got the complete floors. So for example, we now put up to 2 floors, unload and reload. That would then generate 2 floors that the player has, and then the starting area where they would have on the 3rd floor here. So floor 0, floor 1 and floor 2 is where we would have the starting area in this situation. And then it just builds up like that. We're using the old world coordinates system, so we've got an area of 21 kilometers roughly, so 21 kilometers roughly. As these floors are about 5 meters each, so that gives us around 4,000 floors we can generate, so which is far more than the player would ever want to actually go through, I think. So yeah, we can generate levels much bigger than we actually will use. So yeah, so for example, and then we unload that, and 3 floors, we get the same process. No preview. -5, that would be right. Okay, so we would generate the floors, and then we have the top level there, where the player would start, and then they would have to work their way down. So we put up to 10 floors. We get the same thing, just with more floors. And where are we? And so it's the generation can work like this, and it creates the floors one at a time, because we're not creating it as like a giant, just where we have like a stairwell up the middle. We have it so that the floors are very different arrangements each time, so that they're not always the same shape. As you can see here, we've got parts poking out, and yeah, it gets it's very different. It's designed so that the each floor is is a very different shape. So we'd use, although we're using the same room designs all the time, they would always get a very different layout each time. So for example, they would need to we wouldn't need to worry about remembering where everything is, because it's just always in a different layout. So we can generate as many different layouts as we want, and we can have so there's more rooms per floor or over a different area. So we could have very rectangular shaped areas where we would generate different shapes in, so that we can prevent it from being too wide or too narrow or things like that. If you think of the way we generate floors as the first layer of randomness, and how we generate the randomly generated levels, then the second layer of how we do that is how we use combinations of streaming levels to create the walls and internal features within the rooms and the levels. So the way it works is that we have a basic template room called a geo level, which is just the outline shape of the room, and then within that geo level we then have gameplay levels which provide the decoration, and then there's feature levels which provide the purpose for the room. So for example, if you think of it as the empty undecorated room is the geo level, and then we provide decorations on the walls and litter on the floors and so on as in the gameplay level, and then the feature section can provide a specific feature for that room. So for example, with larger rooms we have a larger number of features and combinations that we can have. So we start off with our geo level here, which is just the very basic outline of the room, and then we would add in the gameplay, which provides the decals on the floor and dirt on the walls and the various decorations that we have to make this room. And then the third layer would be that we have different features within these rooms to create different experiences, and we can reuse the same room each with different parts. So for example, we rather than have a complete room each time, so for example we have room 1, room 2, room 3, we can reuse parts of room 1 and with different decorations. So if we have room 1.1, room 1.2, 1.3, 2.1, 2.2, 2.3, and like that, so on. That way we can we don't have to have complete levels and load in these complete levels when we don't need to. We can show and hide the parts we don't need when we're not actually going to be using those, and the player isn't actually in that area yet. So we can save resources when the player is not actually near the area and they don't actually need to see the extra decals and extra things, causing the frames to be more complicated to generate. So we start off with just this to reserve the area, then we provide decoration to it, and then we provide a feature to it. So in this case we would have internal walls within here, so that the player would have to have different things to do in each of the rooms. So one set of internal walls, another set, and yeah. And so we can also reuse these parts as, for example, the boss room. So for the end of the level, the player would have the boss room where they would fight the boss in the centre here in this game. So if we hide this for a moment, would have the boss here, and then he would have his own features within his own unique room. We can all, because we're reusing the same streaming levels over and over again, we don't need to have several copies of essentially the same room just because we want the boss room. We can use the base of the original geography plus the same decorations plus with the feature for just that boss. Okay, this is how the generation system will work for the clutter and the static meshes and the various decorations that we'll have in the levels that are randomly generated. Because we rely very heavily on randomly generated content, the content needs to be both different each time, and it also needs to fit together nicely. So for example, you don't get things that clip into each other and just don't look correct together. They look odd. If they look odd together, then it makes it look bad. So the way it works is we have three types of decoration within the level. We have standard static meshes that don't change throughout all the individual rooms, and then we have hideable meshes, which is stuff that can either be shown or not shown. So the more hideable meshes that you would see, there is a hard cap on those. You wouldn't see any more than there is available to actually show. And then there's the third type, which is clutter. Basically, the stuff that you see on the floor here. It's stuff that you can have an unlimited amount of, but you basically should have some type of maximum if you want to. What the player will see is roughly what we have in front of us here. This is actually the same room that's copied 3 times. It's just the same room, just rotated down at different angles, and then we automatically just use the other filters we have to create different things like different dirt on the wall, different litter on the floor, and so on. So, as you can see, if we take this trash can for example, we always have this trash can plus bricks here, and then 2 pallets. The same we have there, trash can, bricks, 2 pallets. So trash can, rotate around to the right. And same here, trash can, rotate around to the right, bricks, pallets. And same again here. Trash can, bricks, pallets. Okay. The second part is where we have the highball meshes. So, for example, we have 3 bags here, and we have 5 bags, so 6 bags there. And then we have 4 bags there. It's the same arrangement of bags each time. It's just a case of where where there are different positions, they get randomly shown or hidden according to their location. That's how the highball meshes work. So we take out all the various bits of trash. Okay, here we have the same 3 rooms again, but this time with all the non-essential meshes have now been hidden. So for example, we don't have any litter on the floor, and we don't have any of the other parts. So for example, we don't see the trash bags around there, around any of the other bins. So this is how the base level will look without any of the randomness to differentiate rooms. So we still have the same 3 rooms. The essential stuff is all in the same place, but we don't have any of the randomness to make the 3 copies of the same room individual. So for example, we still have the bin, bricks, pallet, so on, green, bricks, and pallet, green, bricks, pallet. Okay, here we go again with the normal settings for just the highball meshes, the stuff that has a hard cap on, how much of it can be shown. These are the normal settings that the player would see. They could increase or decrease these meshes if they wanted to. For example, if they want to increase their FPS, they may, for example, turn these off or decrease them, so there will be less of them. So if we check our bin, we see we've got 3 bags in front here, 5 bags there, and 4 bags there. Same 3 copies of the same 3 rooms, but we have some slight variations. We have the meshes done differently. So for example, you see these 2 copies of the same sets of bricks. They have different jerry cans and things around them because that's how we create the variation for these. So for example, we have 2 sets of the same bricks, and with spent bags on top and jerry cans around the side. Different combinations of jerry cans at different places. So for example, we go over to here, we have the same bricks, and we will put no jerry cans this time because they've just been hidden in this version of the room. Okay. Same with the cones in the middle of the room. We have different layouts of cones each time, although they are actually it's the same copies of the same cones, but some of them have been hidden, some of them haven't. Here we have the same room again, but we're not hiding any of the highball meshes. So for example, that means we get all this extra dirt on the walls and here, and we always get the same combinations of meshes that we could potentially hide or show. But there's a hard cap on these meshes. We won't create more than we ever need to, because they're basically just set out to always be as a maximum. So for example, we always have the same a combination of bags here. Same, see? And with the jerry cans and the cement bags on there, you always see the same combinations all the same time, because we're not hiding anything. This is, if the player wanted to, they could set it to not hide any of these meshes, and we always get the same combination. Like so, the same as if we hid all of them, we always get the same combination of nothing. Here we have the same combinations of everything. each time. And here we are again in the same three copies of the same room, but this time we've hidden all the hidable meshes, and we just have the clutter on the floor and the standard meshes that we would always see. So for example, I've been there, but we don't have any of the trash bags. Cinder blocks, but none of jerry cans or cement bags. Same there. But what is different is the stuff on the floor. This is the standard amount that we would have shown in the game. It's quite dense, but the player could turn this up or turn it down. So, for example, we would get less decals on the floor, so the pattern on the floor would be different. Slightly less complicated to draw, and would have less of these cans and various things. Yeah. Okay, here we are again with the standard meshes shown, but with far more trash than we expect to actually use in the game. This is 10 times the amount of trash on the floor that we expect the player would actually need to see. So yeah, probably allow them to turn up to say 150% of the trash, but yeah, with not 10 times like this. So 1.5 probably be the maximum I would expect that the player would actually see, not 10 like this. But yeah, basically it's because we have all this extra trash here, we can see just how much stuff we can actually cram into the area. And note we get this part here where we don't see any trash, because that's where we have 3 copies of the same room. It's the same square room here. We've just removed the door between these parts here. So we get the same here, because we have a border around the edge of the room where we don't put this trash, so that we don't have trash clipping into other things. So for example, it'd be very strange if you had like a cigarette packet being clipped into one of these pallets or into the trash can here, for example. So to avoid that, there's a slight border around it. You can see it very clearly when you've got far too much stuff put into there. But yeah, it shouldn't be visible for the player when they're actually playing the game, because they won't see this much stuff. Yeah, this just demonstrates how we can have varying degrees of trash and how much we can actually cram into the room. So, for example, even in some of the other rooms, you get lots of trash everywhere. They're all instant static meshes, so it's relatively light to draw and do. Okay, and back to how the room would look for player with the usual settings. So, as we can see, we have 3 rooms, and may have other copies of this room used elsewhere in the level that are have a slightly different configuration. So, for example, you see different configurations there. So, if we walk through here, we have another. And yeah, this is the same. Okay, this is another version of the same room, but this time just as a 10 meter square, because it's there we have other types of rooms surrounding it. So, for example, we have the trash bags here, we have the bricks and the jerry cans there, and then we have pallets there. Again, we have different combinations of things around them as well. And this is how the randomness and the levels are generated in this game. Basically, we use streaming levels and combinations to build the rooms. These rooms then have their own hideable meshes and meshes that they have inside them to make each copy of the room unique. So each instance of the room should be completely different to another one, because there's so many different variations that we can have. It's very difficult to get the same ones. Get them in the same combinations twice. Okay. There are some questions that I expect you probably are thinking, like, for example, am I using Nanite and Lumen? The answer is no. At the moment, these are still still very expensive for VR, and I haven't used them because it's not yet ready for VR on consumer level hardware. The latest graphics cards and things can run it very nicely, but Anything older than the 300 series will probably struggle with that, and that's not what I want to see from my game. I want it to be possible to play on older hardware as well as the newer stuff. Another thing is, am I using frame generation? The answer there is also no, because I did try with FSR to see if it would be better, and generally the only thing I found was it crashed a lot, and it produces artifacts on the rendered image that I didn't like, and it didn't really add anything to the frame rate at all, because basically our frames are already so cheap. If you add in the frame generation, then it's actually almost an overhead on how it creates the frames. So basically you have the frame generation overhead for that, plus generating the original frame. It's basically just expensive, and you don't actually gain anything, maybe 5-10% of improvement in frame rate, which didn't really seem worth it for the amount of crashes and the instability it caused. A good question to ask if you're thinking if you do have any questions, is how I managed randomness within streaming levels, because streaming levels are loaded asynchronously, and even if you use the same random seeds each time, you will get different results from these randomness that you create. So for example, you load up one time, it will be completely different to what you load up the next time, even though it's the same streaming level with the same seed, because the randomness is different with asynchronous loading, because first time it may have loaded that particular room first, the second time it may have loaded it third or fourth times, which means that you don't get the same random sequence of numbers. So yeah, that would be an interesting question to answer for you if you're looking to would like to know more.